Welcome everyone. We are now going to discuss about the network theorems. There are four network theorems: Thevenin theorem, Norton theorem, maximum power transfer theorem and superposition theorem. So Thevenin theorem, in which any complex linear circuit, it can be replaced by a single equivalent circuit or a simple equivalent circuit consisting of a Thevenin voltage source and a single resistor. And this simplification is valid for any load connected to the original circuit. So it will be very much easy to compute the voltage or current for any complex linear circuit. So here what we have to find is, we have to find the Thevenin voltage and then we have to find the Thevenin resistance. So Thevenin voltage is, it is the open circuit voltage across the two terminals where the load would be connected. For example, if I am having a load resistor RL, so that will be replaced, and then here we will be measuring the open circuit voltage. So this is known as Thevenin voltage. Whereas the Thevenin resistance is the equivalent resistance looking back into the circuit from the load terminals with all the independent sources turned off. It is known as the Thevenin resistance. So while finding the Thevenin resistance, all the voltage sources will be shorted and current sources will be opened. And the next is maximum power transfer theorem. The maximum power transfer theorem is the condition for load to absorb the maximum possible power from the source. So here the maximum power delivered when the load resistance RL is equal to source internal resistance, that is RL is equal to RTH. So here also we will be finding the same Thevenin resistance, but we will be equating it with the load resistor, and then the Thevenin resistance will be equal to load resistor. If it is the case, then the maximum power is possible to be delivered from the source. So this is what the maximum power transfer theorem implies. So at maximum power transfer, the efficiency is only 50%, but we will be getting a maximum signal strength. So even though the efficiency is only 50%, half of the power is dissipated with the source itself. So this theorem is important in signal processing as well as in communication systems like antenna matching, where maximum signal strength is more important than the efficiency. So here the circuit which is given here, it consists of one voltage source and then we have three resistors and one load resistor. So here this circuit is replaced, or it has been modified with one single Ri resistance and then RL with Thevenin voltage. So here maximum power is Pth divided by RL plus RL the whole square into RL. So it is Vth square divided by 4 into RL. So this is the maximum power. So consider a circuit which is given here, like a 20 voltage source is given, and then we have three resistors R1, R2, R3 with values of 82 ohm, 150 ohm and 47 ohm, and then we have a load resistor. So here load resistor is being open circuited, and then here when we find the current flowing through the mesh 1, it is about 86.2 milliampere, and then the Thevenin voltage here is 12.93 volt, which is nothing but the voltage across R2 resistor and R3 resistor. So finding the Thevenin resistance RTH, or we can say it as Ri also. So it is find out by this way. 82 ohm is parallel with 150 ohm. So we are taking R equivalent and then we are adding it with the series resistor 47 ohm in order to find the Thevenin resistance. It is about 100 ohm. So here the current is 13 divided by 200, so it is 65 milliampere. So hence power can be found out by I square R, or it can be found out by V square R, or we can use Vth the whole square divided by 4L. So it is 0.4225 watts. So this is the maximum power that can be delivered by the 20 volt source which is given here which is connected with resistance R1, R2, R3 and then RL. So this is all about the maximum power transfer theorem. The next one is superposition theorem. So superposition theorem is used to analyze a circuit which consisting of multiple independent voltage or current sources. So here the total current or voltage will be equal to the algebraic sum of the current or voltage given by the independent source acting alone. For example, if I have three sources, source 1, source 2 and source 3, I will be using only one source and then I will be finding the current value. Then I will be using the second source to find the current value and I will be using a third source to find the current value, and then finally I will be adding all these three in order to get the desired voltage or current. So this is how superposition theorem is applicable. So we will be selecting one independent source and turning off other sources. That is, we will be replacing voltage sources with short circuit and current sources with open circuit, and then we will be calculating the response, that is voltage or current, in the desired component. So we will be repeating this process for every independent source, and then algebraically we will be adding all these values in order to get the desired or final output. For example, consider a circuit which is given in the left side. So it has 5 ampere source and then 20 volt source. So here when only 5 ampere source is acting, then 20 voltage source will be shorted, and then by using series parallel reduction technique we are finding the I dash value. So I dash is the current flowing through the mesh 2, and then it is 5 into 15 divided by 15 plus 2 plus 3, so it is 3.75 ampere when only 5 ampere source is acting. But when 20 voltage source is acting, as shown in the diagram 2, so here we will be finding the I double dash value. So the I is the current flowing through the second mesh. So the current flowing through second mesh is 20 divided by 3.33 is 6 ampere, and then using current division rule we are finding I double dash. So it is 6 into 4 divided by 20 plus 4, it is about minus 1 ampere. So by this superposition theorem we are adding this I dash and then I double dash. So it is 3.75 minus 1, which is equal to 2.75 ampere. So thus the current flowing is found out, but we are finding it out in a different way. We are using only one source to find the one current value, and then we will be using another source in order to finding the another current value, and then finally we are adding it. So this is about the superposition theorem. And the fourth one is Norton's theorem. So this is very similar to the Thevenin's theorem, but in Thevenin's theorem we will be using or we will be having one single voltage source in series with single resistor, but here we are having single current source in parallel with a single resistor. So here any complex linear circuit will be replaced with simple equivalent circuit consisting of a single current source in parallel with a single resistor. So how we are finding the equivalent from the complex linear circuit is we will be finding IN and then RN. IN means it is Norton current and RN is Norton resistance. So IN is the short circuit current flowing between two terminals where the load would be connected, and RN is the equivalent resistance looking back into the circuit from the load terminals with all independent sources turned off. So this is also similar like finding the Thevenin resistance. For example, consider a circuit given here. Here it consists of two sources, 2 volt voltage source and 4 ampere current source, and then we are going to find the Norton current value which is flowing along the terminal A and B. So hence 10 ohm is the load resistor, so we are replacing it with short circuit, and then we are applying a KVL to the mesh 1. If you are applying KVL to the mesh 1, it is 2 minus 1 into I1. So where I value is 2, and then mesh 2 and 3 forms the super mesh. Hence we are writing current equation for the super mesh. It is I3 minus I2, which is equal to 4. So applying KVL to the super mesh, we will get minus 5i2 minus 15i3 equal to 0. So when we are solving these three equations, we will be getting I1 as 2 ampere, I2 as minus 3 ampere and I3 as 1 ampere. Hence the Norton current is I1 minus I2. So it is about 5 ampere. So this is how we have to find the, or we have to construct the simple equivalent circuit from the complex linear circuit using Norton's theorem. The prime difference between Thevenin and Norton is Norton has single current source parallel with a resistor, whereas Thevenin has single voltage source series with the resistor. So all these four theorems are the network theorems, where the maximum power transfer theorem is to find the maximum power that can be used by the load resistor, and then superposition theorem is using single sources in order to find the current or the voltage value. So that this is all about the network theorems. Thank you.